Hi everyone, and welcome back to your channel FE Civil Exam with Farhad. Mechanics of materials. We want to calculate the support reaction in 1 degree indeterminate beam with a distributed loading of W on the top of it. So we want to calculate the reaction at B and A, and also the angle created like theta at B. So to approach this problem, I have provided you with a 4 different solution for this problem. So the first one is like this is definitely 1 degree indeterminate beam, and solution 1 is determination of elastic curve from the moment equation. Solution 2 is considering the moment at A as a redundant, because then it just the 1 degree indeterminate converts to a determinate structure, then you can solve it easily. Solution 3 is like considering the reaction at B this time as a redundant and solve the problem and replace it back. And our last solution is based off strain energy method, which is the Castigliano's method. So I have already solved the problem with these 3 solutions, and I will provide the link to those short videos for you in the description of this video. And to have a deeper understanding, determination of the first solution is just determination of elastic curve from moment. Is a classical solution, and it just involves integrations. The mass solution, we can call it as well. Solution 2 and solution 3 are almost kind of the geometrical solution, and solution 4 is a kind of energy method solution. And if you want to, I just recommend to, for example, make a comparison at least between 2 of these methods to give you a grasp of meaning of this problem. It just gives you a good sense of understanding. And if you make comparison between all of them, that's great. Let's start our problem in solution 4. My channel is mainly designed for US students in civil engineering which are preparing for a fundamental engineering exam, but also it can be used for any person who is interested to understanding the mechanics of materials, dynamics, structural analysis, concrete structures, fluid mechanics, and those kind of materials. But it's mainly beneficial to a civil and mechanical engineering students. So let's get started. So in the Castigliano's method, so if we want to approach our problem, first of all, we do know that the delta at B is equal to 0. There is no a up and downward a movement for reaction at B. And if we just start from point NB and just extend our beam to a length of X, and then cut it through like from here, definitely there is a moment created there, that's mx. There is a reaction at B and the distributed load of W in the length of X of our beam. Summation of moment in around X goes 0, it just gives us, and this is the counterclockwise is our positive arbitrary direction, so it gives us negative mx plus rb times X minus the resultant, which is W, and it applies definitely at X over 2, so that's Wx squared over 2. Mhm. That's Wx applied at X over 2 just gives us this term. And then you can easily jot down the moment equation, and that's m sub x is equal to rb times x minus Wx squared over 2. And we want to calculate definitely the reaction at A and B for such beam. As soon as we have the moment equation in Castigliano's method, which is an energy method or a strain energy method, so definitely if you jot down the energy equation, U or strain energy in beams is equal to the integration over the length of the beam, and strain energy in beams is mainly due to the moment. That's why we have it like mx squared over 2ei dx. And if we want to calculate the deflection or deflection at B based off energy, it just simply Castigliano's method. It just says a partial U over partial of the element that creates that vertical movement. So the only if we don't have reaction here, if we don't have support, the only reason for movement of point B is due to reaction at B. So that's partial U over partial RB, reaction at B. And then if you just simply have it for YB, that's partial U over partial RB. That's equal to the derivation of this equation. It just gives us M over EI times partial M over partial RB. So that's simply like, if you want to know how that works, it's just simply like it is 2mx over 2ei times dmx over dr. So we just replace like these two, what these two cancel out. That's mx m over ei times partial m over partial rb, because this is drb. That's how we can get it here. So we already have our moment equation. We can replace it here. This is our moment equation, just comes here. And the other component is this part. It just comes from partial m to partial r. Due to x, it just x. Mhm. Partial m over partial rb is equal to x. How you can get it here? Then this term goes here. And if you just replace that part in our main formula, it just simply says, if you replace like mx with rbxw x squared, this part, it just comes here. And the other component like partial m over partial rb, which is x, it just comes partial m over partial rb, it just comes here. Then integrate our equation dx. So if you do the math, it simply gives you yb is equal to, take the constant out of integration, 1 over ei, integration from 0 to L rbx minus wx squared over 2 times x dx equal to 0, because we do know that the deflection at b is equal to 0. There's a support there. So if you do the integration and uh, use the limit of integration, it just gives you this equation. Definitely constant cannot be 0, so this part should be equal to 0, and that simply gives us rb is equal to a 3 over 8 wl. As soon as we know what rb is, we can jump to our geometry. The summation of the forces should cancel out the WL, so it simply says if RB is 3 over 8, then RA is simply 5 over 8 WL. And the other question is how we can calculate theta B, and that's the topic for our next video. Thank you. We'll see you on next video.